this going through the water will go through the water. But because of the drag, in other words, it's bumping up against the water and the water is being sucked back here, it causes drag. So we'll look at another drawing. But this cubicle, this geometric deal here, we got three things. First we got buoyancy. That means we have enough to hold the weight. This is a weight. We calculated it out, and this thing here, if I put it on it in a pail of water, it'll float. The second thing it has is something we call stability. That means I could sit on here without the thing falling over. In other words, if I just sit here real quiet, it won't tilt over and tilt over. In other words, if I sit on a round ball, although the ball is buoyant, the ball have a tendency to tilt over. But if I have a nice flat surface, put it out in the water, it'll work pretty good. And then it won't change directions, it'll stay right here. Now if I put the thing this way, it would have a tendency to fall over. But if I set it this way, then it's relatively stable. And we start with the rectangle for the canoe, the raft, a basic rectangle form. And this works. And these little fluted deals work a little bit better. You know, it's a little round and round, you know what I mean, so the water can get between there and you get a little more glide. And then what happened? They began to turn the edges up a little bit. So now when the water hit, it kind of, but you see two boats. You see something we call a hydroplane effect. And it's flat and it goes through the water like this. And this is a basic development. But then you see a secondary development with the canoe. Later on, now this represents a knife that's been sharpened. It's sharp to the front and it's sharp to the back. Sharp to the front and it's sharp to the back. What goes on here? Well, we're going to come back and we're going to talk about it just a little bit.